if we talk about security, there's typically a lot of problems to get time to do security. So I met with quite a lot of resistance sometimes from engineer managers, product owners, etc., that say, our developers already 100%. How can we do security? Well, I think that's the problem in itself, that we think about security conceptually wrong and how we work with security in a team. And what we've tried in the past as well is try to say, okay, you get dedicated time to work with security. So let's say 20% of your time, is that a reasonable figure? Well, it depends. A few years back, we started a developer security community. So we trained software developers in security, and then we asked them to, you get to spend 20% of your time to only do security. And that worked really well in the beginning. Like, people were happy, okay, I get focused time to learn something new, I get to secure applications. But then when you start thinking about it, 20% of one person, of maybe 5 persons, that means 4% of your time spent on security. So that's not really how it works, because it's not about those 20% or 4%, it's about the 100% of how we work with security. And that's a really important figure to remind ourselves. And then, working with security, what is a secure digital product? What do we mean by this, and how do we actually achieve it? And it doesn't really matter unless we actually can measure it. And how do we measure security? And security, and in any digital product, it's just one out of several non-functional requirements, right? We're having security, scalability, performance, testing, and reminding ourselves of the 20% time for security. How many teams actually say that they spend 10% time on testing, 10% time of operations? It doesn't work like that. We're just developing software. And when we try to measure then security, some people talk about vulnerability management or vulnerability scanning. We need to be really careful about what we measure on security. Because thinking conceptually around things such as vulnerability management, you look at how many vulnerabilities do we find. But that's not that interesting, because if you start blaming people who find vulnerabilities, you will stop finding vulnerabilities, which is counterproductive, because we want developers to find vulnerabilities as long as they actually fix them. So what's interesting is rather to look at how does the trend look like. Are we finding vulnerabilities and are we fixing some of them? Then we're pretty happy from a holistic perspective, because that means that this team is actually working with it in some meaningful way. And time is not on our side, because I made the analogy on 20%, but we also very often meet with deadlines. Okay, we need to ship this feature or this piece of software within a couple of weeks. And how do you then balance that with everything else going on? And this very chaotic slide is just a poor attempt on trying to visualize what a developer typically lives through in a global enterprise today. You have all your tech steps, you have daily stand-ups, you have sprint planning, sprint reviews, pull requests, code reviews, and all the text you need to do, not to talk about everything going on Slack. So it's really important then, since time is limited, what do we put into the time when we work with security? So we need to be careful which tools we pick and how do we work with those tools, and what activities do we choose to spend our time with. And hint, we're going to talk about threat modeling here because we think this is really powerful. And then when you think about this, you have everything going on in your daily life. You have very limited time to spend and a lot of asks to yourself. I'm not going to spend a lot of time talking about cognitive load, but I think it's an interesting concept, because whenever we're presented with a piece of information, output from a tool, or a request for something, you need to spend cognitive effort to understand it. In cognitive load theory, you typically talk about how complex is the information you need to have, how can you link that to what you already know, and how much of this is actually just a distraction. And then thinking about cognitive load, you also need to understand the communication gap, and how that there is a communication gap between security and developers. Because a developer today, you typically have a lot of different techniques. You maybe use some obscure JavaScript framework that we in security are maybe not super happy with. And serverless and all these things. And security engineers, on the other hand, typically now also have sometimes an increased broadage of knowledge because you're expected to know privacy as well. So at IKEA, our cyber engineers would typically work with both security and privacy together with teams to be there to support them and to help them. And then it's really hard to find people who are both broad and deep in knowledge. So the two-way communication between security and developers is really important. And you need to be careful. You need to simplify to reduce the cognitive load. And I think everyone here recognizes, like, you're getting some request, someone asking you a question, and you're already occupied, and you're like, oh, I'm not sure that I can work with this right now. So simplifying security and communication is super important. And I think this also, like for security organizations then as well, we need to keep this in mind as well. It's both developers and security that needs to simplify. And the why, I think that this is something that I can speak a lot about, because I love this quote. I think it's from Friedrich Nietzsche, an old philosopher, that the person who knows the why can bear any how. Because when we know why we need to spend time on security, or why this is important to spend time on, we can motivate ourselves to take the time, and we understand why should we spend effort on anything on this. And this goes for everything you do in life, really. If you're motivated enough to do something, you're going to find a way. And at IKEA, this is, for me, pretty simple, because we have something that we think is really worth protecting. We have several hundreds of millions of people's data. And if we would lose that, I don't need to turn up to work the next day, because, cybersecurity at IKEA would not be in a good position then. And this ownership of security that we began this talk with is super important there as well, that if you understand why you as a developer need to take care of something, that's really important as well. So how do we simplify this, and how do we make things faster? Well, automation is of course an interesting concept and something that we need to dwell and talk about. Automation is super important. But if you add a lot of tools after each other, or you start using tools such as SAST, like code scanning, or software composition analysis, where you analyze vulnerabilities in third-party softwares or open source software, if this is an idiot, the tool, and you need to spend time on the output, you need to understand it's waste this precious cognitive effort on output on a tool. To what degree is then that really automated? Because this leads to unmanageable tools, that we're having tools after tools after tools, which typically spits out false positives. And everyone who's used a static analysis tool know that this is a challenge today, because they're crying wolf. And there's loads of teams everywhere where I come and I talk, start talking about security and the importance of fixing this, and I can see that they have a lot of vulnerabilities that they've just stopped to care about, because they're just constantly crying wolf, these tools, and they lose importance. So this precious time, they're not going to spend that on these tools. Because if we remind ourselves how software production is, how we build software, and this is a developer conference, so I don't think I'm kicking in open doors here, but it's not deterministic. It's not like an assembly line where you can just build the same software over and over again. Building software is much like an agile design process. And if you find things in a production assembly line of a car or of a furniture, in our case, it's already too late. And here's a point to be made about the automation of tools. They have their place. We like automation of SAST and composition analysis, DAST, if you have that. It has, it has its place in security, but it's just that. It's just something that finds something in the production line. And some of the most important things that we can find, logical flaws, design flaws, that needs to be found somewhere else than in production line.
Yeah, and with that challenge in mind, finding the right security or that specific type of security flaws, we need to consider what it means to identify security vulnerabilities that are either context-specific or generic by nature. Because if we differ between the two, then that will also affect the balance of tools we choose, or balance of activities in combination with tools. A lot of tools are good at pinpointing stuff that's doesn't matter what context it's used in. Like, let's say it's a third-party library and there is a security vulnerability in it, then no matter how we are using that third-party library, it's a security issue. But it's also important to note that that's not always the case. Rather the opposite, the context matters a lot. Like, depending on if it's exposed in a web application, and depending on, as an example, how valuable would you think a vulnerability related to a Bluetooth library is in a container-based application deployed on the web? Probably not a big issue, at least not if we're working in the cloud. So it's important to find the right balance between context-aware and generic, but also the balance between accuracy in identifying security issues and the coverage in doing so. And by coverage, we mean coverage of different categories of security vulnerabilities. And these are two factors that correlate pretty well. Like, the point we're trying to make isn't that all automated tools are inaccurate. Rather the opposite. There are tools that are more accurate than the others. There are also tools that can be tweaked even further into improved accuracy, and that are quite good at pinpointing security issues with a low degree of false positives. But the end result is usually also affecting the level of coverage. So in some cases, also depends a little bit on what programming language you're in. In some cases, you might have to disregard some categories of vulnerabilities because there is a too high degree of false positives identification. But if we dive into a bit further what it means to do context-aware security, what we usually start with is one of the first questions, or the first question in threat modeling being, what is it that we're building? And to put a lot of efforts into describing and analyzing that, yet describing it in an easily understandable way. And that doesn't necessarily mean that we need to describe the entire system, including all legacy features and all that, but it could actually be the opposite. You could have an accurate model only describing that specific feature that you're building at the moment. And describing the context usually means describing who's using this typical feature. Like, is it an end user? Is it another system, for instance? And what is the data flow? What is the typical use case? What type of data that's being passed in this scenario? And how does it integrate to other systems? Because that will also affect to what degree we're able to complete that use case. If that system is available, if that system doesn't contain any flaws and so forth. So if you have done threat modeling before, you already know about this, that the first thing we do is actually describing what is it that we're building. And if we don't spend any efforts in doing that, then we'll have challenges in the next steps that we'll get to. And if there's one thing that we've learned from several years of threat modeling and doing it with many teams, not only at IKEA, but in other places as well, both small and large organizations, accurate models are so worth the effort. And what I mean with that is, the better we describe actors in legit scenarios, the better we understand what are the abuse actors or the threat actors that could potentially exploit that, and under what preconditions. Like, imagine if we have an authenticated user, then we probably also have an attacker with potentially having access to valid credentials that we need to consider in our threat model. And also, in terms of accuracy in the model, also describing things like what are the different dependencies, like what type of systems are we integrating with, and who's responsible for those systems. Going back to the discussion of automation, and this is important to emphasize, the point we're trying to make is not like automation is useless. Because like that's a no-brainer. If we can automate stuff that we're doing manually, why should we do it manually? So what we're trying to say is rather the opposite. Like if we're able to create accurate models that are context aware, that are accurately describing how this piece of software is being used, and in what situation it's being used, what type of data it processes. If we can describe that automatically, then that's awesome. Whether that means that we need to point to our code, point to our cloud provider, point to everything that has to do with our system development, pipelines and such. But if that can be automated, then of course we should use automation, and we still should use tools like static analysis, software composition analysis to enrich that data in the model. And the other way around, of course, we can more easily interpret the results of the tools if we have a description of the software. And the better that model describes the software, the more we reduce the cognitive load in working with the security findings and working with that model, whether it's one of the members of the development team or if it's a security specialist coming in and doing a periodic review or something. If we go to the next step of threat modeling, identifying what can potentially go wrong, then again, of course, we could potentially go from a generic perspective and identifying what can potentially go wrong in a web system. But that's not really threat modeling, right? That's more of a checklist-based security. Let's say that we could go by a OWASP top 10 and say, like, is this applicable to us or not? Is this applicable to us or not? But that would be a high degree of manual workload. It would be especially a challenge if we were to do that feature by feature. And we've seen situations where people try to do this with like 300 plus security requirements. And that obviously becomes a challenge, and it's frustrating and annoying, causes a lot of friction in the development teams. That's not what we want to do. But one valuable input again to this is the accurate model, the description of the software that we're building. And the better we describe that, the easier it's going to be to describe what can potentially go wrong. And even if we were to automate it, the easier it's going to be to automate what can go wrong, still doing that from a context perspective. We realized this a couple of years ago at IKEA, that it's going to be a challenge when we do threat modeling at scale if we want to teach people to understand what can potentially go wrong. And we tried out a concept called threat library, where we defined common challenges, common security threats, if you like, depending on what type of technology you're using. Let's say that you have a cloud-based database, or if you have a serverless application, then there are certain things to take into consideration. And we formed something called a threat library out of that. But as you can see from the example that we have in the slide, it's quite obvious that this is also generic by nature. Like, of course, we can tag it and say this is only applicable if you're using JSON Web Tokens. But still, a threat saying an attacker modifies a valid JSON Web Token in order to impersonate another user. Yeah, it's a valid threat in some applications, and the mitigation is usually to ensure that you're doing proper validation of the JSON Web Token, including all elements of it. But going from such a threat, it also becomes a challenge to describe, for example, to a product owner or to a senior engineering manager, what's the actual problem? What's the actual business risk of this? So the more narrow and more context-specific we can describe those threats, the easier it is to get leverage to fix it. So I wouldn't say that there's something wrong with using the threat library, but there are at least a couple of downsides. One is the generic by nature. It's also that we learned from practicing this at scale that people tend to take the easy way out. Like if there is a threat library that you can assess against, then just focus on these ones so that we don't have to handwrite our own threats. Because especially if you're new to threat modeling, it's not necessarily an easy thing to just write your own threats and come up with what is a valid threat scenario. So it can easily become a sort of security requirement assessment, and that's not, then we're basically going back to those 300 plus generic security requirements. So we are taking a next stab at this, and I'm going to talk about that in a while, but again, I'd like to emphasize on the importance of actually analyzing the model we've created. And by analyzing that, we bring up context-specific threats. So our next stab is something we call the threat composer. This is actually inspired by an AWS Labs project. And we continue to use the same form of threats that we have taught people to do when doing threat modeling, where each threat has a who, what, and impact. So someone who is performing or being the threat actor of that threat, and how or what type of action that person or actor is doing, and what is the potential consequence or impact. But the point with the threat composer is that you'll have predefined suggested threat actors, and in the long run, suggested threat actors based on what you have modeled in your application. So if there is a legit authenticated user, then we can already suggest that there are internet attackers with valid user credentials. For instance, doing manipulation of an input parameter, and the impact of that is affecting a call to another service. This is just to technically describe what it could be, but if you were to have predefined consequences in your model, then you could have even more accurate descriptions of what the potential impact in this business system is. So as you can see, by selecting predefined options, it's a lot simplified to define threats one by one. And it's easier to put this closely into context of that software system that's being produced. And again, this is a big challenge where we have observed people that are doing threat models for the very first time. When they are supposed to list threats, the first question they ask is, okay, what do I enter here? And if it's one thing that we want to avoid when we do threat modeling at scale, is something called the blank canvas syndrome. Like, we should never put just blank canvas in front of people and say, hey, go ahead and produce your threat model. We need to guide people into doing so, and guiding them, the easiest way to guide people nowadays, as you all know, isn't just to say, hey, go ahead and read this book. Because the best way to do it is with software, and having software driving that methodology. If we zoom out a little and talk about what can potentially go wrong in the larger perspective, it's also one thing that we have talked about this at a quite early stage when rolling out threat modeling, that of course it's not only about what each specific software system team is doing with regards to security, it usually fits into the larger picture somehow. Like, if we have, like Gustav said, thousands of developers, not all of them are working on software that's exposed to the internet. But it can still be part of a critical business process and something that needs to be taken seriously if there is a vulnerability or not. And again, in order to reduce that cognitive load in understanding how do my system fit into the larger picture? We believe that it's a great value to combine these threat models and to see, like, we basically already did the job, right? When we identified what are different dependencies, what are the uses of my system. We have basically started to construct that graph already. And by putting the system into the larger perspective, we understand that if there is a potential threat, then the mitigation might be better suited in that other system that we are dependent on. And we can, by doing this bottom up, we can describe what are the relevant business processes and how do they actually integrate with each other. And we believe that's stuff that should be done bottom up, and it should be owned by the teams, because that's the only chance we can keep such data up to date. It's impossible, right, if we were to do that top down and try to identify this is a critical business process to us and try to map what different teams are involved in contributing to that and what are the different software systems that we need to take into consideration. This doesn't necessarily mean that all software system teams are supposed to do everything in threat modeling. Rather the opposite. We think it's fine to have shallow threat models or granular threat models in a couple of teams. And it's usually a lot better to have a threat model describing one or two features that we have recently developed than to have nothing. So we shouldn't strive for perfection. And because if we strive for perfection, especially, to be honest, security specialists tend to strive for perfection, right? They want to do everything. They want to spend hours and hours on analyzing your specific system. But that might not be what you really need as development teams at the moment. You might just want feedback on this design of this specific feature that you're working on at the moment. And we should be completely okay with that. Because if we start doing something, we can enrich that threat model later on. And adding new use cases, even adding legacy use cases because someone else says that it's important to our business process, or it's important for us as a dependency from our system. So if we look at where we are getting next, we think that there is a great value in threat modeling piece by piece, both within each specific team, but also for the organization as a whole. And if we have models, even if they are quite shallow, and if you compare with, for instance, C4 diagrams in architecture, if you have the system context level, which is the highest abstraction level, then that still serves a value in terms of identifying the different dependencies and the key data flows. And if we have such models, then it's easier to provide accuracy and coverage to our other tool findings and activities like code review from security perspective, detection and response playbooks, disaster recovery plans, and so forth. And this is going to be, or I would say it is, a challenge today. We have good security operations centers, SOCs out there that are doing a good detection and response job, but many of them are struggling with identifying what are the key use cases or what are the relevant anomalies to look for. And that's something we can pick out of the models if we have them produced. So to summarize all this, the culture, security culture and ownership is extremely important.
And there's a lot of benefits to gain by when we have developers engaged in these threat models that we've been talking a lot about, and all the things that the threat model can span into creates a much clearer ownership of security when developers understand their threat models. Because if you see this is actually where things will hurt us as a business if something happens. And I think to Emil's point of that you don't necessarily need complete threat models everywhere, but when developers have a concept of doing threat modeling as a part of the software development processes, we're going to build much better systems because we know what's important, and we can actually also let that steer other security processes, such as where would you actually focus your vulnerability management if you understand your threat model.
How many of you would say that you have a good, clearly defined ownership of security in your organization today?
Well, a few.
A few.
And I think this is a really interesting concept, because there is some service out there which will say, when you ask, who is responsible for security? A lot of developers actually answers, we are as developers. But the security professionals, they also say, we are responsible. So that there is a split, and it's not super clear, and it's typically the case that it's not clear in organizations. And we can see that just within IKEA, that is a fairly large organization, that depending on where you go, you have different perceptions of ownership of security. Because depending on how security professionals act and work with teams, you get different outcomes on this.
And of course, we also realize that security can mean many different things depending on who you ask, and there are multiple perspectives to it. But in general, we suggest keep it simple. And that goes for cognitive load in general. Like, if we can start talking the same language and respect that many security specialists, to be honest, aren't that good at software development because they don't have that in their background. And the other way around, of course, there are many developers that are quite new to security challenges. But the best way to meet is to start trying to understand the different perspectives and use simple terms, especially for security specialists, to start using the terms involved in software development rather than trying to describe what stride is and understand what each element of stride means. And once you have talked about what spoofing is or tampering is, then you need to describe what that means in your development scenario. And I would say just take a shortcut around that.
And really important to be made here as well is that when we think about how software is made, you typically build feature after feature after feature. And the most important thing, especially what we're trying to change how we do threat modeling at IKEA right now, is rather focus on the feature instead of the complete picture. Because you already have your focus as a development team on the feature that you're building. So if we can stay focused within what you're already working with and making sure that that feature ends up secure with the right processes, the right tools, you spend less cognitive effort of thinking, I think everyone who's been a developer has looked at code they wrote 6 months ago and thought, what the hell is this? And I think it's the same thing when we try to secure that afterwards. If we can get that into our ways of working, I think that's super powerful.
And again, automated security, there are several benefits in automation in general, of course, but there are also challenges, and be critical about before you bring in a tool or a ways of working with regards to automated security, to question to what degree are we able to not only identify potential security issues, but also interpret the results. And this again emphasizes the cognitive load. And once we have interpreted the results, triaging if this is an actual problem in our context or not. And again, the accurate models, the importance of it. If you spend a lot of your efforts in describing what is it that we're building, even if it means building a specific feature, then you'll gain that once you start looking into what can potentially go wrong. Even if you ask others to help out in understanding what can go wrong. The better the model is, the easier it's going to be, and the more accurate the end result is going to be.
And here comes the ownership back again. Sorry for talking so much about that. But if developers are involved in threat modeling and preferably driving it as well, you have that ownership of the module, and you care about why it needs to be accurate. And we've made some mistakes like that. And when I started rolling out some application security practices at IKEA, we did too much for the teams. And if we do too much for the teams, they feel like they're taking care of everything. And whenever we come with an output or an outcome, a pen test report, a report of some sort of tool, people have no connection to it. And they don't understand why this is important. So yet again, like, we need to come closer, we need to simplify, and that's really a super important message for developer security. Any questions?
And I think we might have a couple of minutes for questions.
As soon as possible, and I think that's the generic answer, but we have some success stories from this when we've actually taught developers in our Security Champions program. I haven't talked a lot about that, or I didn't even mention it, but we're training a lot of developers in some security practices. And the best case of threat modeling, the best story I have from that is I had a few developers came to me and said, we got this feature request. We were asked to develop a feature where with a zip code we could find the customer. And just by thinking about that, they realized this will lead to user enumeration, because they could actually think about how would we implement this feature and think about what can go wrong if you start asking the wrong way there. So that's where we really see the benefit, because then we restructure that feature before it was even built. Now that is of course the success story I have, but in general, whenever you can start threat modeling, you should do it.
Yeah, and I would say the greatest power with threat modeling is that it's really agnostic to what step in the process you do it. But in general, as early as possible, but I know that's also an idealistic scenario. But in practice, it can be both. But I would say the main beauty of it is that you can start analyzing without having any code, and that's difficult for the other type of security tooling that you use.
But I meet a lot of skepticism from developers when we start talking about threat modeling, because threats and these things, risks, it sounds so complicated. But we ask the questions like, what are we building, what can go wrong, what are we going to do about it, and how do we verify it? Everything is in the threat model manifesto, which we're taking a lot of inspiration from. But if you boil it down, it's about asking what can go wrong. And if you are developing something that you are passionate about, trust your gut. Because getting to that point of your gut feeling about, is this actually something that can go wrong? What happens if I don't, if I trust this data without sanitizing it, if it's not coming in the right schema, etc. I think there is a lot to gain just by getting that way of thinking, or however we want to say that. Any more questions? Okay, thank you very much.
Thank you.